Okay, let's start. Hello, everyone, and welcome to this week's colloquium. Today, we are pleased to have Professor Steve Potter from, yes?
You can hide it.
It's only on.
From Zoom, isn't it?
Oh, yes,
No,
sir. So you came, eh? I'm in a meeting now. So can we arrange for tomorrow at 12?
I think it's that one. Has it gone?
Yeah, because sorry, then just an agent meeting just came now, so I need
don't have it on my Zoom, so.
What time for me is it? Oh, okay, yeah, tomorrow at 12,
Yeah.
ne?
That,
Yeah.
and then
All right, chef.
is there a disabled one? Okay, it's fine, it's fine. Let it be there.
Go away.
It's all right. You can see the caption. That's okay. No, some people might need it. Yeah, so Prof. Steve Potter from SAAO and University of Johannesburg, and he will be talking about the Intelligent Observatory. And thank you, Prof, and the floor is yours.
Cool, thanks. Hi, everyone. Thanks for coming, and anyone who's online as well. Great to see you here. So I thought for the next while or so, we'll give you an update on the Intelligent Observatory program, where it is right now and where we think it's going. And then hopefully by the end of the presentation, I'd like to hear from you guys as well, what you think about the steps are moving forward. So I guess the Intelligent Observatory program started in about 2018 maybe. So back then, you know, the observatory's always been on a program to upgrade its facilities and operations and that sort of thing. Back then we asked the question, what do we need to do in order to keep SAAO relevant and internationally committed? And that's where we formed the Intelligent Observatory program. So at the beginning of the program, we kind of
the TV mission should exactly follow those. That's for edge field lasers. You always like when you see correlation X-ray.
What do we need?
Okay, this is one
What are the main things we need to do to remain relevant and internationally competitive? So we kind of came up with a list of a few key things. One is, for example, being able to allow our users to submit observation requests at any time. So not just once a semester, at the beginning of a semester, but at any time. How can we allow science to be made on any time scale? So not just those short few-second exposures to science that covers 1 week, but science that goes over weeks, months, and years as well. How can we change operations so that we allow our users not just observe in Sutherland, but maybe from here in Cape Town and maybe from anywhere else in the world? And then how can we change operations so our users can continue to manually operate the telescopes, but maybe use other modes of observing as well, like queue scheduling or service observing? And how can we change our operations so that our telescopes not only can be manually operated, but can respond to computer-generated requests? So kind of remove the human from the observations entirely. And then finally, basically, how do we advance operations so that we are better at coordinating science across all the facilities in Sutherland? So this was our initial vision, and I've put green ticks each to next one because I think we've achieved that. And over the next few slides, I'll kind of show you what we've done. So at the beginning of the program, we focused on our 3 kind of workhorse telescopes. These are the 2 1-meter telescopes and our 1.9-meter telescope. And between these 3 telescopes, we offer the community basically all the fundamental ways of doing astronomy, whether it's spectroscopy. And I need to hide that menu. One sec. Hide.
Okay. No, I think what I wanted to say, most of is to say that I can't meet at 9 o'clock.
Oops. No.
Okay. Sorry, man.
So between these 3 telescopes, we offer spectroscopy, colorimetry, imaging, photometry. They're all the fundamental observing modes in astronomy. And we supply that through the 3 telescopes. So at the beginning of the project, in order to deliver on those bullet points at the beginning, we had to upgrade all 3 of these telescopes from being manually operated to, first of all, being able to have them remotely operated. So all 3 telescopes can now be remotely operated from anywhere in the world. And just to give you an idea of what that means, this telescope, 1-meter telescope, is now, I don't know, about 12 years old, I think. This telescope is about same age as me. You can guess my age if you want. And this telescope is about the age of my mother. So there's still about the same age as my son, I think. So we have 3 generations of telescopes there. But as far as a remote observer is concerned, they've no idea, right? All 3 telescopes have been upgraded to the same level of technology. They can remote observe. Doesn't matter how old the telescope is, it's delivering the signs that you want. So beyond that, the SAAO 1-meter telescope, we further developed that telescope to be a fully autonomous telescope. So this telescope now is fully autonomous. It's a robotic telescope, which means at nighttime, no one is operating that telescope at all. Instead, it has its own list of targets that it wants that's been assigned to observe during the night. And at the beginning of the night after sunset, it opens up and then works through the list of targets. At the end of the night, it closes down and then sends an email notifying the PIs that their observations have been taken. So I should note that for that project, one of the big software components was something called an observatory control system. So this is a high-level piece of software that's the interface for the users to submit their observations requests into the queue. It looks after the queue. The queue is a live queue as well, so it updates every minute. So the queue can be changed on a live basis. Astronomers can submit requests to the queue, and it can be put into the queue straight away. So there's an adaptive queue. So this software we took advantage of the Las Crumbas Observatory. So in Sutherland, we host some telescopes that are part of a worldwide network of telescopes. They were originally called the LCO GT. So GT stood for Google Telescope. So it was funded by Google, and they open source some of their software. What happened there? Okay, so this first vision was all about automation, basically. We were absolutely obsessed with automation. Think of any process, we figured, right, how do we automate that? I could talk for weeks on all the little software projects that automation projects, and this is just a sub-list of some of them. But at the end of it, we have a lot of dashboards, and this has become a bit of a problem that we'll come back to later. But also we've produced things like quick look spectroscopy products. So not only does that robotic telescope observe during the night autonomously, within 1 minute, we release fully calibrated spectroscopy that can be downloaded straight away. We use various, for example, machine learning techniques. Just before sunset, the telescope needs to know whether the sky conditions are ready to do sky flats. Now, to do sky flats, you must not have any clouds in the sky. So the telescope, it uses the live web camera, and it uses intelligent algorithms to determine whether there are clouds in the sky or not. And if it's a cloudless image, it will automatically submit observations to the queue, so that after sunset, the sky observations will be automatically taken. Okay. The other thing was the OCS, which I just said. And then there's a lot of low-level software developed as well. Like, for example, that Nakud, the SAAO telescope, it's capable of doing not just imaging and spectroscopy. And as most of you know who do spectroscopy, long-slit spectroscopy, you need to point that telescope to sub-pixel level so that your target is in the slit. And we've automated that process entirely. And it wasn't just software that was part of the upgrades. We also identified a couple of key hardware components as well. And one was the instrument selector port for the 74-inch telescope. So before this, even though I gave that list earlier of spectroscopy and imaging and polarimetry that you could do on the telescopes, you could only, on the 74-inch, you could only do one of them at a time. So if you wanted to switch from spectroscopy to imaging, during the daytime, the technicians would have to take off the spectrograph and put on the imager. And that was a 3 or 4 hour process. So in reality, instrument changes would only occur maybe 3 or 4 times per year, because it was such a schlep to do. So we recognized that this was a bottleneck. And so during this phase, we went from preliminary kind of sketchy diagram all the way to designing and manufacturing it in-house, and eventually then deploying it on the telescope. And you can see that's Nick there chewing at his knuckles, wondering if his measurements lined up correctly. So this was deployed last year already. So now this means instead of having an instrument change maybe 3 or 4 times per year, you can now change the instrument as many times as you like while you're observing during the nighttime at the flick of a button. So this is a big upgrade to the usability of our telescope. And of course, we introduced remote operations, and as part of remote operations, we constructed our kind of flagship remote operations center. And it was really great to have the Minister of DSTI to open that. Okay, and so just to finish off this part, ultimately, all these upgrades are to enable science. And so this isn't the science talk, so I'm just going to quickly show you 3 examples as proof that we've achieved these goals. So this is one project where we're following up on supernova explosions. So this is spectroscopic follow-up of supernova explosions. So the supernova have been detected somewhere else in the world using an imaging survey, and this now automatically follows up those supernova in order to identify what type of supernova they are. And so these observations are generally programmatically put into the queue with no human in between, so that they minimize the amount of time it takes to get onto the target. So that's kind of the transient side of the program. For quick follow-up, quick immediate follow-up. The other types of observations we do now is, which would have been impossible to schedule before, would be to monitor targets over several months. So you can see here, this is from February to May, so I don't have about 3 or 4 months. And here we can see we're monitoring a so-called micro lensing event. We wouldn't have been able to do this before, or it would have been very difficult to organize. And then the final thing as well, remember I said we want to be able to coordinate science across multiple telescopes better. And this is one example that was published a few years ago. So Zuido's in the audience here. He was the first author on this. So we managed to publish the first simultaneous salt and meerkat observations. It's not in the title, but this data set also included data from our Meerlik telescope and the 1.9 meter telescope as well. Okay, so that was our vision formulated back in 2018-ish. So then after that, you know, if we're given all those green ticks to our bullet list, what do we do next? So then we thought, what's our next vision? So we came up with a new vision, and this time, so this was a couple of years ago, I guess, and you know, ChatGPT had just been released, and so the AI race had begun and was accelerating quite quick. So we figured, right, how do we advance SAO astronomy and telescope operations into this kind of so-called fourth industrial revolution? And we were fortunate at this time as well to start a new partnership with an institute in the UK, an institute called the Hartree Centre. Like the SAO, the Hartree Centre is a UK research institute under the Science and Technology Facilities Council, which is the equivalent of our NRF. And thanks to the UK government, they provided funding for us to partnership with them for a couple of years on a few projects. Hartree their expertise is in supercomputing, big data, and artificial intelligence. So this sounded like a great opportunity to move our project forward. And so there are two main projects underway in collaboration with them. One we're calling the telemetry project, and the other one we're calling the RAG project. And I'll just describe a bit what they mean now. So the telemetry project is basically about, we want to create a unified login system that's recording everything that our telescopes and instruments and software services and databases, every minute is making a record of what all of those are doing. And we want to do that so that then will enable us to perform things like health checks, fault analysis, maybe do some preventive maintenance as well. So having this telemetry data, you'll be able to predict things that go wrong before they go wrong. And also this telemetry data will enhance our astronomical data as well in enabling advancing our data products. And so, yeah, invest in equipment behavior. So you can imagine, in order to create something like that, it requires upgrading of all of our software services so that they're providing telemetry data. That telemetry data just doesn't come out of thin air. It requires a whole upgrade of all of our software. And then, of course, you need to create a database, design a database, and deploy a database that's going to ingest all of that telemetry data and make it available for analysis. So we've already done that. Don't need to worry about the details of this. We've already started to do that. We've already incorporated the 3 telescopes I was mentioning earlier, in addition to some other software services. So this is just a web front end. So we've also designed a web front end that enables you to investigate and analyze all that background telemetry data. So that's a lot of telemetry data. And so the sort of things that you can then do is you can create plots like this. So this is just a plot. The red line says whether the Sadie dome shutter is open or closed. And the blue plot is the atmospheric humidity levels. Now, for an automated telescope, you have to have trust in the software that those shutters will close when the weather turns bad. And with a fully robotic telescope, there's no one at nighttime watching the telescope to see, is it going to close when the weather turns bad? But with a live telemetry data set, you can now automate this monitoring, or you can go back and see, was the telescope closed down during bad weather? So one other example, which I think is quite interesting, is In each of the domes, we also have a web camera, and the web camera is recording audio. So for experienced observers, when when you're working in a dome, you get used to all the sounds and noises in the dome. Like if you hear noises, you begin to identify, well, that's just the telescope slewing, that's just the dome rotating, or things like that. There's hundreds of noises that you get used to. So then when a strange noise appears, you know that doesn't sound right. I better stop what I'm doing and go and investigate before the catastrophe happens. Now, with robotic telescopes, you don't have a person in the dome anymore. So if something starts making a horrendous noise, the telescope is just going to continue trying to observe and making a bad situation potentially a lot worse. So we're now recording audio, and we're using machine learning classification techniques in order to teach the algorithm what are the normal sounds in the telescope. And then it uses that model to compare it to live sounds and raise an alert if there's a sound that it does not identify. Either raise an alert or just stop what it's doing. So that's the sort of thing you can do with a telemetry database. So a couple other things we've done in the meantime. We've also made a science database. So with all 3 telescopes, we've now databased all the observations over the past 12 years, I think, and it's now a fully searchable database. Okay. So that was the telemetry project. The other project, or the 2 projects, is called the RAG project. And to be honest with you, I never thought I'd be standing in front of an audience and be excited to talk about document configuration management. And apologies to anyone here whose job is document configuration, but what an awful job. Anyway, so in my mind's eye, this is what I think the documents across the observatory looks like. Okay, we have documents all over the place. Technical documents, specification documents, user manuals, websites, HR documents, policies and procedures. It's a complete mess, right? It's almost impossible to go and find a piece of information that you want because we don't have an overall document configuration management system. However, AI technologies are advancing. So now one of the projects is, can we create an intelligent interface to all of our documents? And there's 2 technologies that have become relevant. One is large language models, like ChatGPT, for example. And the other one is retrieval augmented generation, or RAG for short. So the combination of these 2 is possibly now providing us with an opportunity for us to create an intelligent interface to all of the observatory's knowledge and information. And there are some technical details for this. We have to deal with things like addressing intellectual property and personal information and all that sort of thing. So that's also part of this project, and we're learning about that as we go along. However, we have already made our first experimental pilot project on this. And so far, we've only ingested all of the Intelligent Observatory documentation. Okay, and that's already hundreds of documents. And we've also created a front-end interface to this. So you might think this kind of looks like the ChatGPT interface. So it's kind of using the same front-end interface technology, a kind of a chat interface. And so now, we can test it. For example, we can say, sometimes we go on a rotation basis for running a piece of software called the pre-flight software. But sometimes it might be 2 months till it's our turn to go on duty, and then it's like, I can't remember what the pre-flight commands are. And you have no idea where to look. So now we can just ask this interface, please remind me, what are the pre-flight commands? And it will go through its intelligent database and it will find the answer for you. But not only that, So one concern that people have with large language models is hallucinations. How do we know that it's telling the truth and not just made up a nice story for you to please you? This then also provides the actual document in which, a link to the actual document in which it extracts that information from. So you can go and double check on the answer. So this is just another example. What are the pointing limits of the Rossetti telescope? And you can see here at the bottom that it actually extracted the information from our TOPS wiki page. So you can click on the link and it will take you directly to the information. Okay, so that's those two projects, and you can imagine they're still ongoing as we build up the telemetry database and the tools associated with it, and the RAG database as we ingest more collections of documents. But now, that's fine, but now we want a new vision, right? What should we do next? So now we're starting to think about vision number 3. And one of the problems so far of Vision 1 and Vision 2 is we're always being victims of our own success, because we've created all of these new tools. But each one of these tools, this is just a subset of them, each one of these tools has multiple dashboards or a user web interface to interact with them. So the thing then is, thing with dashboards is they're nice, but you know, they show you the live information as what's happening. But unless you have someone who's sitting in front of the dashboard, or hundreds of dashboards, and looking at it every minute, 24 hours a day, what was the point of the dashboard? Okay, and we have a lot of them. And also for all of these user interfaces like the telemetry database, unless you know how to use it, how are you going to extract the information that you want? So there's lots of dashboards and there's a lot more skill sets that we've developed, but we haven't trained the people or hired more people to use all these tools. So what do we need to do next? And this is part of our third vision. And what we need is an AI observatory assistant. So this is an AI assistant who is an expert in all of these tools and looks at all those dashboards and makes decisions and informs us of everything that's going on. So this is our vision, and we've already deployed an experimental AI in our systems. So this AI, we've trained, we've given it access to all of these services, and we've trained it on how to use it, just like if it was a normal human assistant. So now, just like the RAG database, this assistant also has a chat interface. So we've also put on top of it a kind of chat interface. So now we can start asking it questions. For example, please provide me, what did Lasady observe last night? Now, if any of you wanted to find out what Lasady observed last night, what would you do, right? The answer doesn't immediately come to our mind. To those of us who are even work on this project, we would still have to find out, oh yeah, I guess we need to go to, there's the OCS, I suppose. If it hasn't been more than 24 hours, the plot is still there. Or we can go to the science archive if it's later than 10:30 in the morning, because then it's archived, or we can do a search, blah, blah, blah. So, and then you have to know where those tools are, and you have to know how to use the tools, okay? But now with this AI, who is an expert on this, we can just ask, what did Lasady observe last night? And here it is, it's given an answer. And you can see this is the list of target names that it observed last night. And you can see it observed a couple supernova, a few near-Earth objects, part of the NICS program, a couple of gamma ray bursts, ZTF, the Zuido, not Zuido, sorry. They're not that famous. The Wiki transit facility. and another supernova. So great. So there's the list. And it was clever enough, and we didn't teach it this, right? It was clever enough because some of these observations, like the NEO ones, there might have been 200 observations of that. But it was clever enough to realize it's not going to give me a list that long of all the target observations. It's realized that there are repeats, and it's just said, I'm giving you the list of the unique target names. Right? It's done that without asking. So that's cool, and it's offered as well, would you like to have a CSV file of all that? And if you say yes, it'll create a CSV file. So then on that previous slide, so you can see, it observed a supernova last night. Let's check it out. Can you produce a quick look spectrum of that supernova that was observed last night? So it went away. It knows that there's a quick look spectroscopy tool that it can use. And so it knew the name of the object, it knew the time it was observed. So it attempted to then get the quick look spectrum. And the answer it came back was actually last night, even though that target was observed, it wasn't a spectrum, it was just a normal image. So I can't make you a spectrum. But I'll tell you what, I will search the entire science database, which is another skill, to see if that object has been observed spectroscopically any other time in the past. And it did that, it found. So last night was a couple of weeks ago for this particular example, but it searched the database and it found something in August 2025. A spectrum was made of that supernova back in 2025. And then it says, and then it gives a link to a website that you can click on, which will then show you the fully calibrated spectrum of that supernova. And on the same website, it also gives you the raw image and the raw spectrum and also the acquisition image. And you can see in this image, there's the galaxy, and that's the supernova there that it took a spectrum of. So I didn't tell it to do that, right? It realized that image was not a spectrum. And if it on its own, it decided, maybe I'll try and help him out, see if there's a spectrum in the database. And it just went ahead and did it, which was quite remarkable, I think. And so that's kind of the astronomy base, but this interface is there also to help technical staff as well. So you can imagine, all our equipment is not perfect. Sometimes they have issues. So a couple of weeks ago, we had an issue with the GPS time on one of our cameras. And so you could ask part of what we also have what's called a fault forum, which is a database where technicians have recorded all of the faults over the past goodness knows how many years, and sometimes they've written the solution as well. So now, if a new issue arises, you're at the telescope, and there's a problem with the GPS time, how do you go about fixing it? The first thing you would think would be, well, I'm sure this must have happened in the past. I wonder what the solution was. Where would you get that information from? You're on the dome floor at the telescope. Okay. Ask the assistant, is there anything in the past that says anything about this fault? And it'll extract from the fault reports. And here you can see there was a similar one a few weeks ago in April, but similar results going back to 2021 and 2020 as well. And then links, and it actually then describes what the faults actually are and help the technician fix the problem. Okay, so that's kind of technical things and astronomical things. So this AI assistant, as I've demonstrated, it seems that it has more capabilities than what you just trained to do. So this is another example from a couple of weeks ago, and I didn't ask Paul for permission to do this, so I hope he's okay. So Paul Rabe has been, part of his work is doing work on the prime Japanese telescope. So he's occasionally doing some software work for them. But as an observatory and a financial thing, we need to keep track of the amount of hours we work on our hosted facilities. So we asked Paul, can you just keep a record of the hours you work, just as a record? So he made a Google spreadsheet and noted everything down. And then about a month ago, we realized that we have this SAAO website where technicians record the hours that they work on our hosted facilities. For the same reason, it's a financial thing, so we can claim back from the owners of the hosted facilities. So we're thinking, well, I mean, ideally then we need to ingest this spreadsheet into this website, right? But now imagine that you have to do this yourself manually, okay? So you made a spreadsheet and now you go to this website. On this website, you have to enter each one of these one at a time. And it's worse than that. Right, each one of these boxes is a drop-down menu. So you have to click on that. You have to go down, where's prime? Oh, there it is, there at the bottom, do that. And then the date is another pop-up calendar. You have to click on the calendar. And then the next one is another thing. So all these drop-down things, one at a time, is an arduous process. So I figured I'll ask our AI assistant, can it just do this for us? So the AI system, so previously, you remember there was a web chat interface. This AI assistant also has a Telegram interface, so I can chat to it on my phone via Telegram. And so this is a Telegram interface to the AI assistant. And this is what I told it to do. I described in a short paragraph. Paul has made this Google spreadsheet. Here's the link to the spreadsheet. And then here's the link. I told it, can you ingest this into the work hours login system? So I hadn't taught it how to do it. I just gave it the links. And this is the response. Done, I've imported it, blah, blah, blah. And then it does a check as well. It confirms that there were 34 submitted, and it's confirmed that 34 were ingested. And then I went to the website as well, just to double check that it did it all right, and it worked, right? So this is an example of where I haven't taught the AI a skill. It's now clever enough to, you just set it a goal and it will do its best to try to achieve it. Okay. What I haven't shown here, though, is there were some intermediate questions. It did stop occasionally and said, this is what I think you need to do. Can you confirm yes or no? So it does do that sort of thing as well. Okay, so just to finish. So this vision 3, I hope I've given you some ideas of what maybe an AI assistant can do now. It's not that they're now becoming clever enough that it's not just teaching it skills of everything that we do at the observatory. You can also set it goals on kind of everyday mundane things. So are we now moving into an era where, how many of you are sitting down at a PC every day where you do a lot of mundane, repetitive tasks, which you can now just ask an AI assistant to do for you? Okay. So on that, thanks for listening.
Right. Okay, what is?
Two questions. First one is, one of the things you didn't talk about was the sort of someone working out how long I need to observe, and all of that. So does the sort of software that you mentioned earlier on also handle that bit, whereas I'm just a student. My supervisor says this up as this bright. Like, what setup do I need to use on any of the telescopes to achieve what I need to do? Does it do some of that as well?
I haven't tried it on something like that. I'm not quite sure whether it will.
If you could just.
Oh, okay. So Moses was asking, could we ask this AI assistant, if a student, for example, has an idea for a target to observe on the telescope, what would be the recommended exposure times, instrument setup, and that sort of thing? And I think that's a good question to test it. And I think it will attempt to answer your question. And I think it will also follow up with follow-up questions. So it will start with a basic question, maybe asking you for more information. And it will also depend on how much documentation we've ingested into that RAG database. So as that database grows with more documentation ingested, like all of the SALT, PIPT, user manuals and things, it will have access to that information in order to give better answers to that question.
And I guess with the documentation, how do you handle old documentation being updated? Because sometimes maybe in general people aren't good at sort of keeping good version management of things. So then could it be using an old bit of information versus a new bit of information?
Yeah, good question about how to handle old documents and how to update them. So that RAG database is a database that needs to be maintained. And so on an ongoing basis, when there's a new document, you need to ingest it into the database. And it would help as well if your document has, headings that describe the date at which it was created and things like that. So then when the AI queries the database, it can return an answer to you and say, data from this document dated in 2018 says this. This document dated 2025 says this, and it will construct an answer for you like that. But yeah, that requires ongoing maintenance as well. If there's a new document, you need to have a process to ingest it. You can automate that probably, but yeah, that's an ongoing process.
Okay, we'll answer one more question in the room and then questions online. Patricia?
I have two questions too. Am I allowed to have two as well?
Yes.
First of all, congratulations. I think this is a great start. It's to you and the team, Steve. It's really, you've got a long way in a relatively short time, and it has obviously got great potential for the future. Could you just comment briefly about the storage? I mean, the viability of the long-term storage, both of the science data and the other data. When will you run out of space, and are you backing all this up in a different location?
That's
be in trouble with it.
That's a very good question. So we haven't, as an IO team, we haven't taken responsibility for the backup of our science data. That's kind of in the hands of the IT department. But then you're right, we've developed a lot of tools and software. We back those up ourselves. The machines are also backed up internally, but we're hoping all of our software is on Git version control, and we use Bitbucket to upload the versions off-site as well, and things like that. And then things like the RAG database, we haven't made our own separate backup of that. But actually the RAG database hasn't been installed locally yet. That database is still at the UK Institute. So we're going to deploy that locally here quite soon. So when we do that, we'll definitely bear that in mind. That
obviously is a risk. But when will you run out of storage? I mean, what are we really? Do we really have enough? You don't know.
I don't know the answer to that. Yeah, that's an IT question. Sorry.
Can I try a completely different question, please? I'm interested in the coordination, the international coordination of these things. And obviously you're trying to coordinate things within SAAO, SALT, so on, and that's a very important start. But there is a big interest in coordinating these things internationally. And it's not simply your problem, it's in a sense everybody's problem. Do you have any thoughts on how this can be managed and who ought to be managing it? Particularly in these days of the political stresses have become much larger in recent times, and so it almost becomes more difficult now than it was 10 years ago. Do you have any thoughts about how this ought to be progressed?
I guess there are two answers, right? There's one is around enabling that to happen, and the other one is then managing it. So we've been focusing on the enabling of connecting to the international community. I mean, Nick, for example, can talk to you about his near-Earth object and asteroid programs where they collaborate with Atlas and NASA and all that sort of thing. And we have research groups looking at transient alerts and all that sort of thing. So we've certainly enabled it. As far as managing our partnerships with the international community and navigating the world political stage, I don't know how to answer that question. That's quite tricky.
But
Yeah.
people are thinking about it.
I mean, you're right. I mean, we have this partnership with Hartree, which is a UK institute. At the same time, we're formulating a BRICS program, which involves Russia, right, and Iran.
Yeah.
We're definitely keeping each other informed. We're not hiding this from anyone, and we don't intend to keep anything secret. So as far as I'm concerned, as long as we're open, telling everyone what they're doing, then they can decide whether they want to be part of what we do or not. We can't do that for them.
Okay, let's ask online. I think Hartmut, if I'm correct, pronouncing correctly, please unmute.
Yeah, okay, I hope you can hear me. I think it was Patricia that asked the last few questions. She touched on something, and I'm actually being interviewed this afternoon on the electricity demands of data centers. So, yeah, clearly this is probably going to have some sort of impact, but never mind. The point I want to come to is something else. You mentioned it, and I think you are able to do such a good job on that because you are, as you say, an experienced observer. You spend weeks and weeks at the telescopes. So when you hear, as you pointed out, if you hear certain sounds and if you see certain humidity going up, you know exactly what that means. What worries me, so it's not so much a question to you, but to SAAO and the astronomy community in general, is these days, a lot of people, what they see of astronomy is just really what they see on their screen. They don't get the sort of experience on the ground. And I admit, I also use LCO a lot. But I think the reason I'm able to interpret the data much better than I would be otherwise is because I've had all this experience at the telescopes. So how is SAAO and the astronomy community in general going to get around this problem where the up-and-coming astronomers just won't have had this experience at the telescope, where you ultimately are going to be able to really see what the actual problems are and so on? How's one going to get around that? Because what I'm seeing, and we can see that at SAAO, the telescopes are underused at the moment. Why? Because students are not interested in going there anymore. Okay, thanks.
No, that's a fair point, Hartmut. Thanks for that question. And yeah, you're right. We have to keep a careful track on how we, particularly the SAO, how we incorporate usage of our telescopes into the training of our students. And to some extent, the remote observing has given a lot of students more access to our telescopes that they wouldn't necessarily have had access before. So not everyone likes traveling and staying in Sutherland, and they don't have the time to do it. That doesn't mean that they don't like observing. And so I think remote observing has given some students that opportunity and postdocs to to do that sort of thing. But you're absolutely right. We have to be careful moving forward that we don't lose that human skill set of understanding how telescopes and instruments work in order to do proper good astronomy. Thanks, Ahmed.
At the same time, though, you can say that no one knows exactly how a computer operates on the bit level down to, like, if you click a mouse, you actually know what signal is sent to the computer, but you use it every day. So I think at some point it's going to be like that, right? Where students and people in astronomy are never going to see a telescope, never going to touch a telescope, but the data from that is still going to be useful for science, right? It's inevitable. That's the way the world is going.
Could be. I don't like to predict the future, but that is a.
You know what Hubble sounds like. You never know what JWST, what temperature sensors, what sounds.
You just want to get everything around. So for me, it's also a bit scary that why do you need to get it?
Okay, yes. Go
I
ahead.
was following up on was comment about keeping up updated documents. Have you ever considered using agentic AI? I don't know much about it, but it's more like you have an agent managing specific section of what you're interested in, and you got a bigger agent communicating to that.
Yeah, so I didn't go into the technical details of this AI observatory assistant, but it's basically using that technology. It's agentic AI. So it's using OpenClaw. Some of you might have heard of OpenClaw, and you might be cringing right now, but it is exactly that. It's agentic AI.
Yes, and my second question was more about the live queue updating. I think on our vision one, you mentioned something that the queue is live. Anyone can just submit a target at any time and you add it to the queue. What happens if the queue is full? How does that software then decide which block to remove and which one to add?
Yeah, so great question. So not anyone can submit an observation at any one time. You need to already have a pre-approved program, and all the programs are given a priority. It's already been through a time allocation committee. Each of the science programs have been ranked against each other. And so when an observation request comes in, it's associated with a particular program of a particular priority. So if two come in of two different programs, the program that has the higher priority will take the queue.
I was thinking about more where the priorities is.
If the priority is the same, then it will be other factors like where it is in the sky and its observability. There's multiple variables that eventually decide on the structure of a queue at any one time.
Well, the priorities are never the same. For the program to be submitted, we don't.
Okay. So they're ranked, and that's their ranked order. There's no equal ranking. Okay. In addition to that, we have targets of opportunity, priorities, and normal priorities, and what's the other one? Rapid response as well. So they have.
Yeah, and my last question is on about the credit. I think on we agree why you actually took it and actually go and fetch data and present it to a voice system. How does he know that this data I can provide to this specific user? Or my question might be wrong. Who is actually using this AI?
Well, that's a good question. So this AI hasn't been deployed to everyone yet. And we need to decide how we're going to manage data access and who's allowed to see what and that sort of thing. So at the moment, this tool is being made for operations staff. So, you know, we all have permission, if you like, to monitor all the services and software and telescopes and instruments because our job is to look after them. But if it comes then to scientific products and data, we need to be careful on how we release this moving forward to external people. So that database that I was showing you, it's a fully searchable database. It doesn't allow you to download data, but it does allow you to at least search everything that we have. And yeah, so you're right, good question.
Sorry, can we just go quickly through the online questions, because there's a comment and 2 questions on the chat. I wonder whether you can read them. So that's just a comment, and then there are 2 questions.
Okay. Yeah, so Willie was noting about 3 or 4 instrument changes per year. You're right, back in 1987, during the supernova, there was all hands were on deck to do multiple instrument changes all the time. Unfortunately, we don't have that sort of need to rush up to the telescope every night anymore. But I'm sure, actually, if an event like that happened again, right now, we would have all hands on deck to go beyond what we can currently do. Question about Roford. Okay, so question from Roford was about agents and how they interact with large language models, because that can become quite costly. And you can very rapidly run out of tokens because these agents, they're given the freedom to, you just set it the goal and it will go off and use up your full subscription in an attempt to reach its goal. So you're right, we have to be careful with that. And what we're also looking at is how to host our own large language models on site. So then we're not token limited. And actually that relates back to one of Hartmut's question earlier as well, where he was talking about the effect on the environment, because these large language models are power hungry. And we do have a program at the observatory where we're going to start installing solar panels to take a lot of the electrical load, particularly from our IT department. So if our large language models are solar powered, we're at least partly addressing that environmental aspect. Was there another?
Yes, and Brad has a question related to Patricia's.
Which one? Oh.
How do you ensure?
Yeah, so how do we ensure POPIA, as you said, that we're not sharing personal information? And you're right, that is a big headache at the moment. And we're fortunate that we're working with the Hartree Institute, because they are having to deal with this with all of their clients and customers and every bit of research they do. So they are audited a lot by the UK government. And so personal data information is a big deal in the UK as well. So all the lessons that they're learning, they're bringing to our project as well. And yeah, so that they'll help a lot with that.
All right, maybe one last question. Yes, if you'd like to go, Patricia.
I just thought it was worth remarking, Steve, that the question that Hartmut raised about students not learning about the environment is part of the fundamental things that universities are worried about at the moment, not just to do with astronomy, but about training PhD students, training future researchers in the age of AI. You can't, and you don't want to forbid the students from using AI, because using AI effectively is a very important tool for doing research. At the same time, if all astronomers will need to find a way of dealing with it. It is an important question, even though the points that Rudy made are very relevant. And I certainly don't know what the answer is. Good luck.
Good luck to you as well. Don't look at me for the answer.
quite evolving. We are moving from humans doing things to machines. Our focus will now be somewhere else. On how do we then get these agents to do better? To casually find better stuff than what as a human being you can't actually reproduce. We should just have to evolve.
Yeah, I think so. And so the title of my talk was, was about connecting people to systems and data and AI. So I think that's the era we're moving into at the moment, is being better connected to our data and our knowledge. That's what the projects we're looking at. It's not AI replacing us. It was AI enabling us to have access to our knowledge and our data and all that sort of thing.
Okay, I think we ran out of time. Let's thank Steve again. Thank you, everyone, and see you in the next Colloquium. Thank you.
Thank you very much.